All right, so this is the test review. So the first one says to solve it through substitution. So we have y equals 3x plus 5 equal and y equals x squared plus 1, and it's going to solve the nonlinear system. So first one, substitution here. So I'm going to go ahead and use 3x plus 5 as my sub equation. So this is my sub equation. I'm going to plug it in for y. So we have 3x plus 5 equals to x squared plus 1. Since it's a quadratic function, we're going to subtract everything to the same side as the squared term. So I'm subtracting 3x and I'm subtracting 5. So negative 3x minus 3x, 5 minus 5 is 0. And then we have x squared minus 3x. And then we have 1 minus 5, which is negative 4. Now I'm going to try to attempt to solve this first by factoring. If that doesn't work, I'll do the quadratic formula. So for this case here, x method, b is negative 3. A times c is negative 4. We divide by a, which is x. And the two numbers that add to negative 3 but multiply to negative 4 are going to be negative 4 and positive 1, because negative 4 plus 1 is negative 3. Negative 4 times 1 is negative 4. So we come up with x minus 4 and x plus 1 equal to 0. Set each one of those equal to 0. So we add the 4 on this side. So the first one we get is x equals to 4. On the other side, we subtract the 1, and we get x is equal to negative 1. All right, from here, it's an ordered pair, so I'm going to find my y value. So we're going to take x equals 4 and x equals negative 1, and we're going to plug it into this first equation right here. So y is equal to 3 times 4 plus 5. 12 plus 5 is 17. So my first answer is going to be 4 comma 17. That's my first solution where they intersect. My second one, y is equal to 3 times negative 1 plus 5. So negative 3 plus 5 is going to be 2. And so my second answer is going to be negative 1 comma 2. All right, there we go. So 3 times negative 1 is negative 3 plus 5 is 2. Okay, good. All right, on to the second one, which says to solve it by elimination. So for this one here, our terms are lined up, but you'll notice that nothing actually cancels out. So what we'll do here is we will, let me expand this a little bit, make it a little bit nicer and easier for me to write on. Okay, so I'm going to go ahead and draw a line here. Oh, sorry. I'm going to multiply here. Now I want to eliminate the y's. So if this is 4y, to get rid of it, you have to do negative 4y. So I'm going to multiply this by 4. So 4 times 3 is 12x squared. 4 times negative y is negative 4y. And 4 times the other side times 2 is 8. Now I'm going to rewrite the top one underneath it. So negative 10x squared plus 4y is equal to 10. Now we're going to combine our terms. 12x minus 10x squared is 2x squared. 4y minus 4y is 0. And 8 plus 10 is 18. Now we're going to solve this by square root to divide by 2. X squared is equal to 9. To get rid of a square, we take the square root on both sides. Don't forget our plus or minus. So x is equal to plus or minus the square root of 9 is 3. So over here we have x is equal to negative 3 and x is equal to positive 3. We're now going to take this and we're going to substitute it into one of the equations, and I'll just take this one here. The numbers are smaller. Even though those are negative, the numbers are smaller. Okay, so we have 3 times negative 3 squared minus y is equal to 2. Negative 3 squared is 9. 27 when you do 3 times 9. We're going to go ahead and subtract that 27 to the other side. So negative y is equal to negative 25. Divide by negative 1. Y is equal to positive 25. So my first solution is x comma y. So negative 3 comma 25. On the other side, we're going to plug in the 3. So we have 3 times 3 squared minus y is equal to 2. Again, this time 3 squared is 9. minus y is equal to 2. 3 times 9 is 27, minus y is equal to 2. Subtract the 27 from both sides. Negative y equals negative 25. Divide by negative 1. Y equals 25. So now we get 3 comma 25. And those are my two solutions. All right, let's move on to number 3. So for number 3 here, let's go back to green. So this one says by substitution. And as we can see, the first one is already solved. So I can just substitute in for y. But, I'm going to go ahead and add the x to this side right here, because I'd rather plug in a linear. So y equals, add the x plus 2. All right. So now I'm going to this is going to be my sub equation, and I'm going to substitute it right here. So now we have x plus 2 equals negative 3x squared plus 2x minus 5. All right, I'm going to start by subtracting the x to the other side and subtracting the 2 to the other side. So here, negative x minus x is 0, 2 minus 2 is 0. We have negative 3x squared, 2x minus 1x is positive x, and negative 5 minus 2 is negative 7. All right, again, it's a quadratic function, so I am going to attempt to do the x method. So let's just see if that works here. So on the top, we have 1. On the bottom, we have 21. And we're going to divide by negative 3x. I always prefer to keep that square term positive, but this is fine in this case. Now, you'll notice that 1 and 21, there actually is, that's impossible, because there's no two numbers that add to 1 but multiply to 21. So solving this by factoring will not work. So I'm going to go ahead and do the quadratic formula. So a is equal to negative 2, b is equal to 1, and c is equal to negative 7. And we're going to go and do the discriminant b squared minus 4 times a times c. All right, so when I do this here, I'm going to type it into the calculator. So 1 squared minus 4 times a, negative 2, times negative 1 times negative 7. And I come up with negative 27. Okay. I'm just going to look through my work, make sure everything is correct. So I add the x, subtract the 2. Yep. I got negative 27. Now, hopefully you remember when you do the quadratic formula, x equals opposite of b, which would be negative 1 plus or minus the square root of negative 27 over 2 times a, which would be negative 2. But because of this negative right here, we get an I in our answer, and that's imaginary. So they actually do not intersect. The actual answer should be no solution. There we go. All right, let's go ahead and move on to number 4. So this one says to solve it by elimination. And here we can see that everything's already lined up. So I'm going to just draw a line underneath. Because when elimination, the first thing I noticed is the y's were opposites. We have negative y on the top and positive y on the bottom. So I'm just going to combine my terms. 2x squared, that's the only square term. Negative 3x minus x is negative 4x. Negative y plus y is 0. And then negative 5 plus 5 is also 0. So I'm going to attempt to solve this by factoring. First step in factoring is there a GCF? And in this case, yeah, there is a GCF. The GCF would be 2x. Then I divide each term by 2x. So 2x squared divided by 2x is x. Negative 4x divided by 2x is negative 2. Now I set each factor equal to 0. The first one I divide by 2, and we get x is equal to 0. The second one I add the 2, and we get x is equal to 2. So x equals 0, x equals 2. So let's go ahead and see what this is going to come out to. All right, so I'm going to plug it into this equation right here. It just seems a little too linear, so it's going to be smaller. So we have negative 0 plus y is equal to 5. 0 is not necessary, so y equals 5. So my first solution is going to be x is 0, y is 5. For my second one, I'm going to substitute into 2. So we have negative parentheses 2 plus y is equal to 5. That becomes negative 2, so we're going to add the 2 to the other side. And y equals to 7. So my second solution is 2 comma 7. And there are both my solutions to that problem. All right, on to the next problems. The next one say graph each system. So we're going to solve the systems graphically instead of algebraically. So the first one, you'll notice we have a parabola because of the square term, and we have a quadratic function, and then we have a linear because there's no square term. All right, so let's go ahead and use green for the first one here. So for the quadratic function, the things that you actually need to know, again, make sure you know the vertex. So you need to know the axis symmetry, opposite of b over 2a when it's in standard form. And the vertex, you'll figure that out when you substitute your axis symmetry into the function. And then last, know your a value. And don't forget the pattern 1, 3, 5, and 7 if necessary. All right, so for the first one, we'll do the quadratic function in green, like I said. So we have, there's a is 1, b is 0. So x equals the opposite of b is 0 over 2 times 1, which is going to be 0. So for my vertex, 0 comma, now we're going to plug that 0 into that function. So y equals 0 squared minus 4. So 0 minus 4 is negative 4. Okay, so let's go ahead and graph that point. Negative 1, negative 2, negative 3, negative 4. And now let's go ahead and take a look at our a value. In this case, our a value is a positive 1. So that 1, 3, 5, 7 is not going to change because we multiply it by 1, it stays the same. So remember the process. We go right 1, and then the positive 1, so we go up 1. Then from there we go right 1. The next number is positive 3, so we go up 3. Right 1, then up positive 5. Can't go 7, so that's a good thing I didn't write it. So on the other side, we do the same thing. So left 1, then up 1. Left 1 from that new point, then up 3. Left 1, and then up 5. And then I'm going to connect these dots and make the best graph I can. And now we'll do the linear line next. All right, so the linear line, I'll do it in orange. So we have 2 plus 2y is equal to 4x. So we're trying to get it to y equals mx plus b. So I'm going to go ahead and subtract the 2 to the other side. So we have 2y is equal to 4x minus 2. We'll divide both sides by 2. And y equals 2x minus 1. All right, so my y-intercept is negative 1. That's where I begin on the y-axis. My slope is 2, so I put it over 1 to make it a fraction. So rise over run, so I go up 2, right 1. So from my y-intercept, up 2, right 1, up 2, right 1, up 2, right 1. And at this point, I'm going to circle it because you'll notice they intersect right there. Then from there, up 2, right 1, up 2, right 1. Now back, go here, we go down to left 1 to go backwards. And again, you'll see there's another intersection. So we can see we have 2 solutions. And I'm just going to keep going down to left 1, going backwards to fill the rest of my graph. But the only points I need are those ones I circled. So in this case, my solutions are going to be negative 1, negative 3. And my second one will be 3, comma 1, 2, 3, 4. Hopefully I didn't miscount there. And those are my solutions. So 1, 2, 3, 1, 2, 3, 4. Oh, 5. See? I was hoping I didn't miscount it, but I guess I did. Okay. And there's my solutions. All right, on to number 6. Number 6, we have 2 quadratic functions. So let's go ahead and graph these. The first one, I will do it in blue. I'll color code it right here so you can see I'm using blue. So again, we're going to do the opposite of b over 2a. So x equals the opposite of b. So b is 8. So that's going to be negative 8 over 2 times a, which is 1. So negative 8 divided by 2 is negative 4. So for my vertex, I have negative 4, comma, and now we're going to find that y value. So we plug it in. So y equals negative 4 squared. It's kind of, that's a nice, let's write that again. Negative 4 squared plus 8 times negative 4 plus 18. All right, I'm going to type that into my calculator real quick, just so I don't make any errors. All right, so let's see. Negative 4 squared plus 8 times negative 4 plus 18, which gives me 2. So here I'm going to graph negative 4, 1, 2, 3, 4, and positive 2. Our A value is 1, so 1, 3, 5 does not change. And going up, so right 1, up 1 from that point. From that point, we go right 1, up 3, 1, 2, 3. Right 1, up 1, 2, 3, 4. So it goes off the page, but I can kind of guesstimate where that one is a little bit. And on the left side, you do the same. Left 1, up 1, left 1, up 3, left 1, up 5. Make our graph as smooth as we can. And there we go. All right, the second graph, I'll do it in red. So this is another quadratic function, so I have to do the same process. So let's see, we'll start with x equals the opposite of b. So opposite of negative 16 is positive 16 over 2 times negative 2. And that's 16 divided by negative 4, which is negative 4. So y equals, now we're going to plug it into the function, negative 2 times negative 4 squared minus 16 times negative 4 minus 30. All right, I'm going to type that into the calculator. So negative 2 parentheses negative 4 parentheses squared. And I get positive 2. So for my vertex here, we get negative 4 comma 2. All right, so we go over here, we plot that. Oh, and they intersect right there already. That's nice. Our A value this time is negative 2. So when we do the 1, 3, 5, we're going to multiply them by negative 2. So we get negative 2, negative 6, and negative 10. So let me show you how to do this. So from my vertex, the red dot, I move to the right one first, and then my first A value is negative 2, so I go down 2. Then my second A value is negative 6. From that dot I just drew, I go right 1, then down 6. And there's my dot. I can't go negative 10, it's too far. So I go left 1, down 2, left 1, down 6. Then I make my graph. And there we go. And as you can see, they do intersect only at one point, and that's going to be negative 4 comma 2. And that is going to be my solution. All right, on to the next page. Okay. So we have A, B, and C match the inequality with its graph. Okay. First thing I do when I look at these, I could just test points, but I look at number 7. And with this one here, I can already tell you it's going to be letter C. And the reason why is because it's solid. It's the only solid line. And also, the A value is positive, should be facing up. Now, I do want to show that when you test the point that you will get the right shading. So here, like I said before, I use the point 0, 0. So I just plug this into the function. 0 is less than or equal to 0 squared is 0, plus 4 times 0, 0, plus 3. So we do know that 0 is less than or equal to 3, which actually checks out to be true, which means the shading should be on the outside. So therefore, number 7 has to be C. For number 8, again, there's no equal bar, so it has to be dashed. So A and B are the dash ones. And what makes this a little bit easier is the fact that A is negative, so it has to face down. So just by elimination, we know that it's going to be the answer choice A. But again, you should always, once you figure it out, solid to dashed, is it going up or down, facing up or concave down? You always want to test that point. So in this case, 0, 0 is available. So I'm going to test it just to show it to you. So y is 0 greater than negative 0 squared is 0, plus 4 times 0 is 0, minus 3. So is 0 greater than negative 3? And yeah, it is. So the shading should be on the outside, which it is. And that's why that answer is A. And again, the last one is going to be B because it's dashed and it's less than dash, and the A value is positive, so it should be concave up. And then again, you can test your point here this time. I'm not going to test it, but it should turn out to be true, which is why the shading is on the outside. All right, on to number 10, solve the inequality graphically. All right, so when you're doing this here, first thing you want to do is make sure that it does equal to 0. So I'm going to go ahead and add the 6 back to the other side. So x squared plus 5x. Well, that's a little not nice. So let's try it again. X squared plus 5x plus the 6, we move it over, is greater than or equal to 0. I'm going to attempt to do the x method first. If that doesn't work, then I would go to the quadratic formula. So x method. So we have 5 on the top, a times c, so 1 times 6 is 6, dividing by a, which is x. So we have a 3 plus 2 is 5, and 3 times 2 is 6. So I get x plus 2 and x plus 3. Now notice I'm just making it 6 or 0. And I set each one equal to 0, and I'm going to solve them here. So subtract the 2, x equals negative 2. Subtract the 3, x equals negative 3. All right, and I'm going to graph these where the best that I can. So now, before I graph them, first I see that they're equal to. If you look at the equal sign or the bar, they're equal barred. So that means they should be closed circles. So at negative 3, I'm going to put a closed circle. And at negative 2, I'll put a closed circle. And it's just a rough sketch, so that's why I just put those there. All right, so I'll label this one negative 3 and this one negative 2. Now, the next thing I'm going to do is I'm going to look at my a value. So if I look right here at my a value, even though this is the one I solved, it's still the same a value. I didn't move things around like that. So the a value is positive. And what that tells me is that my graph opens concave up. So I'm just going to rough sketch it. The parabola looks something like this. Now, if you recall from your notes, greater than or equal to, that means on and above the x-axis. So we're asking, where is this graph on the x-axis and above it? So I'm going to go ahead and change colors here so you can see it. So here, this piece right here is on and above the x-axis, just like this is. So they are split apart. So when I write this compound inequality, they should be going away from each other. So this arrow here goes towards negative infinity with respect to the x-axis, and the one on the right side goes towards positive infinity when you're comparing it to the x-axis. So my first interval is going to be from negative infinity to negative 3. Parentheses, and now since that's a closed circle, equal bar under the inequality, that's going to be a bracket, union, and then we start at negative 2, that has a bracket as well, and it goes towards infinity. And there's my solution for number 10. All right, on to number 11. Again, we're going to have to make it set equal to 0 because it is a quadratic function. So I'm going to go ahead and add the 2x over. So 3x squared plus 2x minus 8 is less than or equal to 0. So I'm going to attempt to do the x method, see if it works. B is 2, that goes on the top. A times c, so 3 times negative 8 is negative 24. A value when we divide by is 3x. So the two numbers that add to 2 but multiply to negative 24 are going to be, I think, 6 and negative 4. 6 minus 4 is 2. 6 times negative 4 is negative 24. This one we can reduce. 6 over 3 reduces to 2 over 1x. The other one cannot. So this will be, let me write over here. Let's see, we have x plus 2 and 3x minus 4 is equal to 0. So x plus 2 equals 0. 3x minus 4 is equal to 0. So on this one, we subtract the 2. X is equal to negative 2. On this one, we add the 4. And then we're going to divide by 3. So x equals 4/3. All right. Now, back to my original equation. So when I'm looking at this here, first thing I want to look at, inequality sign is an equal bar, right? So it should be a closed dot again. So over here, let's see, we have a dot at negative 2. So I'm going to put a closed dot here at negative 2. And then I have a closed dot at 4/3. So let's say that's roughly around right there. Next, we're going to identify what it is. So it is less than or equal to. So that means on and below the x-axis. Okay, so we're going to create this graph and we're going to look where it's on or below the x-axis. Now, my a value, again, it's positive, so my graph is going to open up. So I'm going to rough sketch it. And that's what it looks like right there. Now for this one, it says, or is it below the x-axis? So where is it below the x-axis? Well, hopefully you see it's from this bottom part right here. It is on and below the x-axis. So it's a connected segment. They're not split apart. It's one piece. So it starts at -2 and it stops at 4/3. Again, there's closed circles, equal bars. So we put brackets. And this will be my solution right there. All right, let's continue moving on. All right, solve the inequality algebraically. So, you're going to see that when I solve it algebraically, it's going to look just like graphically because I am going to do pretty much the same process. I like to draw a rough sketch. That way so I can visually see where is the part above it and where is the part below it. So for this example here, we're going to go ahead and add the 3 back to the other side. So we have x squared plus 6x plus 3 is less than 0. So just a couple of things. You can see that that is a less than and no equal to. So where is the graph below the x-axis? That's what it's asking us to find. All right, next thing. I'm going to try the x method just to see if it works. We have 6 on the top. A is 1, C is 3. Dividing by ax, which is 1x. But there are no two numbers that add to 6 and multiply by 3. So that's impossible. Okay, so what we're going to do now is we're going to do the quadratic formula. So identify A, B, and C. So A is 1, B is 6, and C is positive 3. So we first do the discriminant B squared minus 4 times A times C. So 36 minus 12 is going to be 24. And I'm going to verify that in the calculator real quick. Let's just not make any mistakes here. So B squared minus 4 times A times C. And yeah, we do get 24. So now for the quadratic formula, x equals the opposite of B. So the opposite of 6 is -6 plus or minus the square root of 24 over 2 times A, which is 2. If you simplify the square root of 24, you get -6 plus or minus 2 square root of 6 over 2. And last, you could reduce this one more time. X is equal to -3 plus or minus the square root of 6 because 6, 2, and 2 are all divisible by 2. -6 is divisible by 2 -3 times. 2 is divisible by 2 once. That's why there's a 1 there. You don't see it. And 2 divided by 2 is 1, and we don't really need to divide by 1. Now, the one thing I need to do, though, if you don't know where these numbers are, we're going to convert them to decimals. So I'm just going to type this in the equation. Again, I think you could have typed it in right here if you wanted to verify it, but I simplified it down there. So I'm going to type it in from here. So -3 plus the square root of 6. And I need to get a decimal, so give me 1 sec here. So -3 plus the square root of 6. And the double arrows above enter converts it. So the first one is going to be -0.551. I always round this to 3 decimal places. And let's do the next one. So it's going to be -3 minus the square root of 6. And I get -5.449. All right. So now when I make my graph here, because I'm still going to make a rough sketch that way so I can visually see what's going on here. So let's change this to blue. There we go. Okay. So here is my x-axis. Okay. Open circles. Notice I'm not worried about the y-axis. I'm only focused on the x-axis. A value right here is positive. So it's going to be opening up. And now I'm going to place my roots where they should go. So the negative one should be on the left. And the positive, oh, they're both negative. My bad. So let's put the smaller one first, which would be -5.449. And the positive one would be, or sorry, the bigger one would be -0.551. All right. So here, you look at the statement I wrote. We're looking for where is it below the x-axis. So where is it below the x-axis? Well, that's going to be this part right here that is below the x-axis. So we can see it's connected piece. So we start with the smaller value first. So negative 5.449 comma negative 0.551. They're not closed, so open parentheses for open circles, and there is my compound inequality. All right, now we're down to the last part here, number 13. So 4x squared minus 20x plus 9. Let's see if I can do this real quick. So we'll change this color to this light blue one here. So first off, it's already set up. It says, where is it above the x-axis? So when I graph it, I'll be looking above the x-axis. And here, I mean, I'll attempt to do the x method. Let's see if that works here. So b value is negative 20, dividing by a, which is 4x. And then we do a times c. So 4 times 9 is 36. So we're looking for two numbers that add to negative 20, but multiply to 36. So let me see if I can do that real quick here. Okay, so let's try negative 18 and negative 2. Negative 18 minus 2 is negative 20. Negative 18 times negative 2 is positive 36. Now, hopefully you see you can reduce here. So this one on the left here, we can reduce it by 2. 2 goes into negative 18 negative 9 times, and 2 goes into 4x twice. And on the other side, negative 2 is divisible by 2 negative 1 times, and 2 goes into 4x 2x times. So now I have 2x minus 9, and I have 2x minus 1, which is equal to 0. Now I set each one equal to 0, and I solve. So I'm going to add the 9. So 2x equals 9 divided by 2. If you want to put a decimal or a fraction, that's really up to you. I'm going to keep it as 9 halves, but I know it's 4.5. If you want to put 4.5, that's your choice. Divide by 2, and because x equals 1 half is really 0.5. Okay, and that might actually help you when you're making the graph, but we'll see. Here is my x-axis. Again, above the x-axis. So I have two open circles because my inequality does not have an equal bar. So I'm going to draw two open circles. My a value is a positive. So again, this one is opening up. Smaller value on the left side, which would be 1 half. Larger value on the right, which would be 9 halves or 4.5. And now I'm going to get my answer. So right here it says, where is it above the x-axis? So this piece is above the x-axis, just like this piece is. Again, like before, this goes towards negative infinity. This other one goes towards positive infinity. So they are splitting apart, so there should be a union and two intervals. So my first interval starts at negative infinity, and it goes to 1 half, parentheses because it was not included, open circle, union, then we start at 9 halves, which is 4.5, parentheses because it's not in a closed circle, and this one goes towards infinity. All right, and that concludes the